And we are here at MinEx CRC, and I'm very excited. We've got Fawna Korhonen with us. How are you?
I'm very good. How are you?
Excellent. How are you finding the conference so far?
Excellent. It's always a good one. One of my favorites.
Excellent. What have been some of the major highlights that you're finding from today?
It's always nice to see where the new technology is. So I really think some of the flagship things of MinEx are obviously the drilling technology, the downhole tools and sensing that they're developing. So it's really nice to get the updates on those.
Yes.
I think that's really game-changing technology they're working on.
That's very cool.
But we haven't gotten yet to the NDI session. So maybe that will be the game changer.
Exactly. Well, yes, I'm hoping we might be able to drill into that a little bit now. So you're part of the Geological Survey of WA, and you led the NDI for WA.
Yes.
What have been some really cool highlights from that?
Yeah, so we don't have the results. I guess we've just really started delving into the sample analysis for those programs. So just doing the drilling was a really big challenge, actually. So we've done 2 campaigns in WA. Our first one was up at the Nifty copper mine up in the Patterson region, so up in northern WA. And when we started that program in 2023, and it was supposed to be a 10-hole program, 10 holes down to 500 meters. And we did 3 holes and the rig failed, which was the first time that had happened. Yeah. So at this stage, the rig had already drilled about 15,000 meters, 15,000 meters for other programs. And it's prototype technology, things are gonna happen. So it was a really good learning experience, not only for us, but for MinEx as well, to have that rig failure. So they worked really hard on site to try to repair it, but ultimately it had to go back to Adelaide for repair. And when that was happening, we were losing our temperature window to be up in that part of the world. So we were trying to think, okay, once it's fixed, what are we gonna do? So we then devised our second NDI campaign, which was in the Nullarbor, so in the Geological region, which is, it was kind of an opportunistic program to really use, I guess, the weather advantage to our window. But what we were aiming to do in that program was to test the technology in a terrain, a frontier terrain that we knew was really difficult to drill. So it's this limestone karst geology. So it's got tons of fractures. It's known to be a very, very challenging place, and that deters exploration. People don't want to drill there. It's known to be very hard. So we really went into that program. There was a geophysical anomaly that we were trying to target, but it really was with the intention of showing explorers that it could be done, proving to ourselves it could be done, and proving to MinEx and the CT rig, really testing its capabilities. But it was to open up kind of, I guess, this frontier space, and that was successful. It wasn't easy, but it was successful. So we got 4 holes out of that. We got beautiful drill core tails into the limestone, which had never been sampled before. And so then when we finished that program, we went back up to the Nifty mine site when the temperatures were a bit more amenable, and drilled 7 more holes up there and finished that in mid 2024. And we finally are now starting to really look at those samples in more detail, analyze them for geochemistry, and that's wrapping into a lot of the work that the MinEx researchers are doing. So everybody's starting to get these samples now.
Really getting stuck into it.
We're really excited to see where those results are going to be.
So what sort of things are you really trying to look at with these?
Yeah, so for that one, for the Nifty program, which is kind of our flagship NDI program, it's looking at the distal footprint of a copper mine. So the intention of that drilling program was to do, a series of drill holes at the mine, and then getting progressively farther out to about 20 kilometers away from the mine. And then what we're aiming to do, and this isn't just GSWA, but this is the MinEx community in general, is looking at, the mineralogical, the chemical, the hyperspectral, and the geophysical changes you get as you go at the deposit further out to try to help characterize what that footprint might look like, and then to ultimately, ideally, use those learnings in true frontier regions where we really don't know anything.
Yeah. What sort of regions in WA would you have your eye on?
Yeah, I think the Officer Basin will be our next, would be a really good test case to apply some of these workflows that we're going to develop through the MinEx researchers at Nifty. The Officer Basin looks quite prospective. It's a craton margin, which we know are really fertile exciting places to look. This integrates really well with our WA Array passive seismic program. So we are embarking, we're about 3 years into a 10-year program to get passive seismic data at 40-kilometer spacing across the state.
Yep.
So we're doing that in 9 different regions. Takes 10 years because the instruments, the seismometers are in the ground for a year collecting data.
Wow.
And that basically images from the surface all the way through the lithosphere. And what's cool about that is that several studies have shown now that these craton margins, or the transition between really thick lithosphere to very thin, so where you go from these thick cratons to their margins, are really prospective. Nearly all the major sedimentary-hosted copper systems occur within a very narrow band of where really thick lithosphere goes to
Starts
thin.
thinning.
Yeah, and the data quality or the data distribution in WA has been very poor up until now. But now we're starting to get some of the first data that's showing us exactly where this lithosphere thickness, this mystery, this magical lithosphere thickness contour is. And as we suspected, the Officer Basin, we think will be quite prospective. And we're seeing hints of sedimentary-hosted copper systems there as well. But yeah, we think the results of WA Array will integrate really nicely with kind of some of the geochemistry work we're doing. And
that's cool.
yeah,
How exciting.
So yes, stay tuned for that.
Yes. So when will some of the different results from the NDI and the array all start sort of really coming through?
Yeah, that's a really good question. I think we're hoping in the next 6 to 9 months we'll really wrap up the results from the Nifty work. And again, this isn't just GSWA, this is the MinEx community. So we hope to wrap that up kind of, I guess, sometime next year, and then take those findings and start applying them to other frontier regions. And that's where this officer work will start kicking in.
So what would you do? What would be the next steps after you've really gone through the results? Obviously, some of it depends on what the results are, but yeah, what would the plan be for next steps after that?
For the next steps after we get the result? I guess trying to replicate some of the data sets that we've gotten from Nifty into these frontier regions.
Yeah.
So that will obviously be, more detailed geochemistry, more geophysics. And I think really to answer some of these questions, we'd really benefit from more drilling, which is one of the reasons why we were so supportive of the NDI programs and the testing of this prototype technology, because we'd love to be able to do stratigraphic drilling more routinely in our work programs.
Yeah.
But to do that with diamond drilling, it's so expensive, and it's hard to get those rigs into really remote places. So that would be a really exciting thing for us to be able to do as part of our normal work. We are thinking of or planning to put in an active seismic line to just try to better understand the crustal architecture, which will help answer some of these questions. But really, we probably need samples. There's not a lot of drilling in that part of the world. And what's amazing is that most of the data we have has come from petroleum exploration wells, not from minerals.
Yeah, okay.
So we do need more data. We do need more samples, I think.
Yeah.
So, but we'll see. We'll see what the options are.
Yeah. So the MinEx community is such a large collaboration. How do you find it like collaborating across state borders and companies and all that sort of thing? Yeah, who are you really working with?
Yep, we work with the Nifty program. It's being really well run by Helen McFarlane, who I know you've chatted with over at CSIRO. She's doing a very good job at corralling a lot of the researchers. A lot of those are CSIRO, GSWA based. We do have some uni collaborators that are working on these things. And yeah, it's a really exciting space, but it's hard. Collaboration's not easy. Yeah. But I think, and with this particular program, being that there were some issues with the actual collection of the samples, and it has been somewhat delayed, and researchers have a finite timeline that they're funded for. So, and they probably had to redirect some of their work as well while they were waiting. So we're kind of in this phase where we're trying to get everybody realigned. New people are coming in, which is really exciting. Even at GSWA, we've had quite a bit of staff that have moved into this work. So we had kind of one group that was working on it. That's changed a bit. We have new blood in there now. So
Yep.
Yeah, I think it's going to be really exciting to see where the collaborations go. Yeah. And it's all going to kick off very, very soon because I think the samples were collected last week, so for analysis.
Oh my gosh,
so
how exciting.
Yes, it's hot off the press.
It's all happening. Oh my gosh. Well, I cannot wait for updates. I'll be watching along, that's for sure.
Fantastic.
And I'm really curious what these lovely specimens are.
They are lovely specimens. Sadly, neither one of them are from Australia.
Oh.
But they're good rocks nonetheless. So my background's in metamorphic geology. So I'm really enjoy metamorphic rocks. They're both metamorphic rocks. This one I collected as a tourist from Scotland. But what's cool about this is that you probably can't see it very well, but the host is a garnet kyanite gneiss. So a pretty high grade metamorphic rock. And all these little black fractures through there are pseudotacholites. So those are fossilized earthquakes. So that's the melting that happens when an earthquake happens. You know, it melts and then quenches and crystallizes really quickly. So this is, a fossilized earthquake in one of the most beautiful metamorphic rocks you can possibly ever find. And these were just beach cobbles. On the,
I didn't even know earthquakes become fossils. Is that right?
Probably most of them don't, but occasionally you get.
Wow, there you go.
That's a pretty cool story.
That is cool.
And I think there's even age. So I think the earthquake was maybe 550 million years ago, and the host rock was metamorphosed about 1,800 million years ago.
Wow.
Yes, so that's pretty cool.
That is cool. And
then this other one has kind of a similar mineralogy, but this is a politic gneiss, so a sediment that was buried and heated from Antarctica. So this one I did collect myself. I did a couple field seasons in Antarctica. And the research project we were doing here was really interested in the partial melting history and how these rocks melted and formed these large granite bodies that we see, which tells us a lot about how the continental crust is formed. But what's cool about these particular rocks is that the sedimentary protoliths to these were exposed in the area as well. So you could go look at what they looked like before they were crunched up and heated and buried and melted, and really get a good sense of the chemical changes that happened during that and how melt pathways connected up and formed, and it just gave us this really cool snapshot of the partial melting process in the crust.
That's so
in
cool.
one of the coolest places on Earth.
I know.
Literally.
I don't think I've ever seen or touched anything to do with Antarctica, so this is very cool.
Yes, and
that is not what I expected Antarctica to look like.
It's pretty diverse, to be honest, but most of the rocks aren't that cool or hot.
Well, you had very cool choices. Wow, what a pet rock superflex. That's
I know,
awesome.
No mineralization here, unfortunately, but
just a bit of earthquake and Antarctica.
That's right.
What a combo.
I'm sure there's some sulfides in there somewhere if we looked carefully.
Well, this has been awesome. Absolute pleasure talking with you.
Thank you
so much for sitting down with me.
Very good.